Okay, so previously, if you got the idea of automation that I have talked about and described in the previous video, then automation is only the introduction for what's called and what's famously known right now in the world by software defined networking, SDN. So automation is achieved by SDN. We use SDN, so that our networks will get automated, or we will achieve an automated network. That's it. So automation is SDN. SDN is automation. You can consider it this way. SDN, or software defined networking, is where you have a software that runs and administrates your network, modifies, changes, configures, troubleshoots your network by a software. Yes, not by you accessing the device, but by a software. And what I mean by software is something like the GUI. Okay, software defined networking, or SDN, is definitely a GUI. All of its applications is like a GUI. The result is in a GUI. So you'll get the GUI, or graphic user interface, the GUI, and you will see new things. So you can drag a device from this place and drop it here. You can maybe click this interface that it will be enabled automatically, and it will automatically connect this to this interface. And maybe there is a background script saying that if device number 1 in some day was connected directly to device number 2 through interface fast ethernet 01, then automatically apply an IP address for this one and an IP address for this one from this known pool, so that they will get reachability. So you did nothing actually. All what you have did for you is that you have just used your mouse cursor and you clicked, like maybe you checked this a box in here in this interface, hit apply in the bottom of the page, and that's it. All of those will happen automatically in a matter of seconds. So this is automation, and you have done that through GUI and by using a software. So through that software you will be able to run and administrate an entire network with its different types of devices. In chapter 1 and in the previous video, when I mentioned a DNA center in chapter 1, and when I talked about automation in the previous video, I was always talking about that SDN, DNA center, and automation is always about gathering, collecting your entire network with whatever type of device inserted or built in your network, and group them and show them under the same software, under the same graphic user interface, and you can control and manage and administrate all of your devices from a central point of management, or a central point of view. So all of that above in the automation part and in the SDN part will definitely need either a controller, which is the main goal or thing or concept that we will study in this chapter, or a built-in scripting that I have talked about in the previous video, which is the Cisco TCL, which is a built-in scripting, and some Cisco devices also support Python directly inside the device. You can use the Python language inside a router, Cisco router, and you will wait for the result when you want, like immediately or in the upcoming few hours, moments, depends on what you modify. So a controller, what's a controller? We have talked about Cisco TCL. Maybe some of us knows Python, which is a scripting and a scripting language like TCL, but this blue guy, the blue thing, which is the controller, what is it? SDN controller is the big guy that does almost everything in this chapter, which is controls and implement the automation and administration. This is the one who is responsible about serving you and automating the results config changes for your network, because you only did one single click using your mouse, and that's it. In a few moments, seconds, minutes, maybe tens or hundreds of actions and configs of changes have been applied and saved to your network automatically. Who did that? The controller did. So for you using graphic user interface in your monitor, maybe your monitor is like a 3:1 ratio, became this rectangle anyway. You have like a graphic user interface with some boxes. Each one of them is showing some data, images, analysis, etc. things. All what you did is that you take this, drag and drop it from here. You check some boxes in here. You maybe add things in here, and then you hit apply, and that's it. What happens is that behind the scenes there is a controller, this one here, and what it will say is that, okay, you want all of these to be done to all of those devices, give me a few moments. He will take all of these orders, read them, apply them to your network, save it, and that's it. So this is the controller. Simply as that is the guy who does all of the automation, who automate or apply, really is the muscles who are applying all this config and automating all of the things after you have just clicked few things using your mouse. Okay, so for a controller, actually, where is the controller and how can I purchase buy a controller or add a controller to my network? It can either be, number one, a software installed in a server. So maybe I have a server, a real strong and heavy duty server with high resources and hardware specifications, and I can buy a software from one of the network vendors, companies that are selling controllers. I can buy a controller and install it upon the server, inside the server. That's number one. Number two, an already prepared and a good appliance with a controller built in inside, like the Cisco APIC or the DNA center. Actually, the APIC is inside the DNA center if you would like it, so Cisco DNA center is good enough. Cisco DNA Center is a box that I have attached its image in chapter 1 when I talked about the network devices and the Cisco DNA Center, and we will talk more about this in the upcoming videos with some details, and we also will show its GUI, how it looks like through the internet. So Cisco DNA Center is an appliance, is a server. That server, it's a UCS server, and UCS servers are Cisco servers. Cisco do produce servers just like Microsoft servers, HP, Dell servers, etc. So Cisco do produce some servers, and their servers are called UCS. So you'll get from Cisco a UCS server with an DNA controller installed inside it, and that DNA controller actually is called APIC controller, which is the DNA controller. This is option number 2, to buy an already prepared appliance. Option number 3 is a remote controller through the cloud. So you will buy nothing physically, you will only buy a software, and you will not see that software and you will not install it. You will only get a public IP address for your controller, which is in the cloud, in that network. Actually, it resides inside the vendor network, and you will access it throughoutly remotely, and it will controls your network also remotely through the cloud, through the internet. The big disaster here is that if one of your devices has lost connectivity to the internet, then how it can be controlled. This is something that we will talk about in the imperative and declarative approach of the SDN. And lastly, the controller uses some tools and applications. The application that you will log into that controller and you'll see its UI. Which application is that? What is that application that's showing all these graphic things, graphic user interface? These applications, the most famous and known of them is Ansible, and there is also others which are called Puppet and Chef. In the CCN exam, you have to know those three of these and the differences between them. And I will of course discuss them in the upcoming videos when we reach the differentiation between them. SDN implementation that I have just mentioned 1 or 2 minutes ago, which is what should happen for your, or if your network devices lost connectivity to a cloud controller, what happens? This depends on the approach or the implementation, the way of implementation that you have applied or designed your network, automated network, to work with. Number one, the imperative approach, which is one out of two options to implement SDN in your network. And this one, the control plane logic. By the way, if you have no idea about what the control plane, data plane, and management plane are, and you have never heard about them before, maybe you haven't mentioned them or mentioned them very briefly or haven't mentioned them at all, then I will have an entire slide and a video talking about them in the upcoming videos, the three planes. But basically, the control plane is the virtual plane or virtual brain inside your network device, router, switch, firewall, etc., that is responsible for decisions and for forwarding, like making things, like how can I say it, because I have really described things about them in the upcoming video. The control plane will be responsible of collecting information of OSPF neighbor adjacency and download them in the show IP OSPF neighbor result command table. You see, so this brain collects information and show them to you inside tables as a result in the tables, and those tables actually do reside in the other plane, which is called the data or forwarding plane. So now you have two brains inside your network. Brain number one will take all the collections, organize them, separate them, and say this is should be showed as a MAC table because here are the MAC addresses with the interfaces, and this one should be will be downloaded or show this information will be shown in the show IP route in the routing table, in the show IP DHCP snooping or show IP DHCP binding. You remember those commands and their showing, so it will collect them, organize them, and will send them organized to the data plane or the forwarding plane in that plane. So it will download them to the data plane. In the data plane there will be an already prepared table called the MAC table showing the MAC addresses that your device knows. So the control plane, the big brain that does all of that, if you have an imperative approach, you have implemented SDN in your network using the imperative approach, the control plane logic will reside completely inside the controller. So your devices will become brainless. They will become dummy. Yes, I'm sorry. Because whomever will decide things from now on will be the controller, and your router, no matter how expensive it is, will only say yes sir and will apply the orders that it will receive from the controller. Okay, the controller has a complete control over programming the forwarding decisions. There are the forwarding decisions of the network devices, also for forwarding, etc., which are things that I've talked about, which whatever the control plane done before, this time those decisions and forwarding and etc. will be happened by the controller and will be sent to the device as an orders, and the device will do them. Devices then will ask the controllers before any forwarding or routing action. Okay, so the routers, switches, and firewalls, your devices will no longer have their personality. They will not be able to do that. I'm sorry. They will be controlled by the controller, the big guy. If it was a declarative approach, remember, actually notice that this is the thing that I was afraid of when I talked about cloud-based SDN or cloud-based controller, because those devices needs always to be connected to the controller because they can do nothing by themselves. They must receive orders from the controller to behave. Just in case they lost connectivity to the controller, then it will be a mess because the old device will do nothing, extremely nothing. Okay, definitely nothing. This is because of the imperative approach, so you need to be very careful with that. In the declarative approach, the controller plane resides within the device, just like before. Thank you. Okay, so now my devices will behave by themselves. The controller then, since it's an SDN, there will be a controller. What will the controller do is actually the controller will declare the requirements of what's the problem for me with the in this chapter. Okay, the controller will declare the requirements of all the forwarding and routing decisions to the networking devices. Okay, so they will receive it once and that's it. The controller will just advise and suggest to the devices that router number one, please, if someone wanted to reach network 10.0, please use OSPF and send it to router number 2, and it will say router number 2, if someone wanted to reach network 172, please use a static route and forward it to router number 3. It will only advise them for one time, and the controller will leave the devices to behave in the future by depending on their selves or themselves. Okay, so this is the declarative approach. The network devices will then decide how to translate the orders that they receive from the controller, those instructions, into actions, and the device, the network device, the node, which is your devices, will act by themselves because they have received the instructions, but they will act. The difference here is that just think this will be faster, of course, because when a router needs to do something, he already know how to do it. It will not actually, it already know how to do it. It will not wait and delay and ask the controller. Maybe the controller is very far. Maybe the controller is down right now. Maybe there is a problem in the reachability between us. So this is the big thing that will happen just in case we have lost reachability. So this is the big benefit of the declarative approach. Okay, so final thing before I finish this video is the SDN architecture. What are the components? What's happening? What network I can call a software-defined network? Which network actually? So there are three main things that you need to understand about the SDN architecture. Number one, the underlay network, which are the protocols and features to get reachability. How to get reachability? Number one, you need to assign an IP address to all of your interfaces. Number two, you need to unshut all of the disabled interfaces. Number three, the different broadcast domains need to have some routing protocols between them to route between them. And that's it. I have reachability over everything. Okay, so number one, the protocols and features, which I've just talked about. Number two, all links must be layer 3 and point to point, meaning that, I'm sorry, this is the future where there is no layer 2 switches. Yes, switches actually have begun to become obsolete. The layer 2 switches, the technologies of having like one device that operates in a single broadcast domain, spanning tree, VLANs, all of this headache is almost gone right now. Any new network or developing network, you will see that all of them are using layer 3 only. And by layer 3, mostly it will be OSPF, because the RIP has become obsolete. Definitely, it's a really old protocol that even Cisco has removed from the new CCNA, CCNP, and CCI. All of their new tracks are now have nothing to talk about RIP. EIGRP is a Cisco proprietary, I believe it is, and it went open standard in 2013, but no one bought it, I believe, because we haven't seen it in any other company. So it's only for Cisco devices, and inside your big network you need all of the devices to operate together using open standard protocols. So this is one of the requirements for the underlay networking of the software defined networking. So you need to use OSPF or ISIS in that layer 3 protocols to get reachability, and also all of your devices needs to be point to point. What do I mean by point to point is that having multiple routers connected together through a layer 2 switch, this will not happen again. You will not see that in the underlay networks of the SDN, because there is an IP address here, but there is definitely no IP address in here, and there is one in here, one in here, and these devices are talking together through that switch. So that switch is bridging the connectivity between the routers. There is no such thing in the SDN networks, but there is actually, just in case you needed high port density, then you will need the SUN, the multi-layer switch here instead of layer 2. Multi-layer switch will enable layer 3 ports and their ports, I'm sorry, within itself, and those interfaces, there will be an IP address in here, an IP address in here, and this link will be called, I'm sorry, a point to point link, because there is an IP here, an IP here, there is a single broadcast domain here talking, a single broadcast domain here, a single broadcast domain here, etc. So these are the three requirements for the underlay network. Once they are finished and all of your network is now it's completely connected, completely reachable, then your underlay network is checked. Overlay network is the next step, which is some virtual networks created on the top of the underlay. It's some logical networks like VRF. Okay, VRF is virtual routing and forwarding. We'll talk about it in the CCNP exam. MPLS VPN and VXLAN, those things that you will find in the CCNP service provider, CCNP data center. Don't get confused. It's some advanced and heavy protocols and things that only service providers use in their data centers and networks. But what I mean is that those things do like create multiple logical separated networks upon your network. So like you have a network with this way, router number 1, 2, 3, 4, this way, and there are customers from each router. For the underlay, you see there are 4 networks connected together. So if someone from this network wanted to reach someone from this network, then sure, it can reach it this way, or it can reach it this way. These are the things that you think will happen depending on the underlay network. After applying the overlay network, now the underlay will be only a physical connectivity actually. We will not depend on the underlay network protocols for routing and forwarding. We will depend on the virtual protocols, those advanced and professional protocols, because if we use like a VRF will separate the routing table of these two routers from the routing table of these two routers. So these two guys will not see these two guys. So if someone from here wanted to reach a destination here, it will only be this way. This other method or other path is not applicable. Okay, it doesn't even exist. They doesn't even see it. So this is a virtual network of the overlay. Okay, this is the overlay. And the last thing that I want to talk about in this video is the SDN fabric. It is the physical devices used to build the underlay, only an identification this is, and those devices can be controlled by a controller. So your fabric actually is the nodes and devices in your networks that are controlled by your controller. Don't forget the controller control all of your network devices with their various types and models, and also it controls and monitors the links, the physical cables. So your entire underlay is controlled by the controller, and that's called the SDN fabric. So I think so far that should be enough for the SDN. Nothing more to talk about. Yes, that is completely separated video that I need to talk about, or can be talked in this video. No, I don't want to make it this headache for you because we have already crossed 20 minutes. So I hope that talking about the SDN implementation and architecture is clear for you so far. Just in case it wasn't, please comment down below in the video. I'll be more than glad to work further with you to have a full reachability. Can you see full reachability, or get and obtain the full entire image of the automation and programmability of chapter 7. So thanks a lot for watching, and I hope to see you in the upcoming video. Goodbye.